Okay, folks, thanks for coming along tonight to listen to this talk. I'm James Westland. Myself and Dr. John Faithful decided to do something to celebrate 100 years of the famous Mull geological map. And this is the presentation that we've put together to talk about it. So it'll take about an hour. It covers quite a lot of ground. And hopefully you'll enjoy it. So here we go. This is a quote from the Memoir of the survey. The Memoir was published in 1924, and the Memoir accompanies the map. It may safely be maintained that Mull includes the most complicated igneous centre as yet accorded detailed examination anywhere in the world. This centre lies within sheet 44 of the 1-inch map. It is an extremely complex map. And there's a lot of people have it on the wall as a wall hanging, like a big picture. Not necessarily for the scientific value, but purely for the artistic. And to my mind, it's an excellent example of art and science. It's not just a work of art, it's a work of science. And tonight we'll find out a bit more about how it was put together and what the future might hold for this piece of art. So the topics I want to go through are just listed here. What's a geological map? Why have a geological map at all? We'll look at early attempts, a little bit of the history of the survey, especially the survey in Mull and Iona, how the work was carried out, how they actually did the work, and the final map that they produced on the Memoir to go with it. We'll have a detailed look at it, and we'll look at the map today and any ongoing work and what the future might hold. So, what is a geological map? That's a good question. Well, geology is earth science. It's the science of the earth. And it's a geological map is basically a map about the ground you stand on, what's under your feet. There are two main types. There's what's called bedrock and drift, or solid and drift. And sometimes the two are combined. So I'm going to look at some examples of this. But first, an early map. This thing is called the Turin Papyrus. It's an early topographical map from Egypt, over 1150 BC. And it was Ramses IV who wanted statues made from a particular type of rock. And this early map isn't just a topographical map, it's a geological map. It actually shows various rock bands and sediments and where the gold mines were as well. So this is the earliest example of a geological map that was created for a very specific purpose, so that you get the stone to build Ramses statues from. Here's an example of a drift map. This is the north part of Mull and Morven. It shows you sediments, alluvium, and all sorts of stuff like that. There's not much near bedrock. It's just basically showing you where these surface deposits are. So we're not going to talk much about that tonight. We're going to look at the solid rock, because that's the exciting stuff. Here is a solid map. This is in the Lochbuie area, southeast Mull, and the various colours indicate different rock types. Sometimes the two are combined. The drift is shown as this sort of ochre-coloured material, and this brown and pink stuff are its actual solid rock. So some of the geological maps combine both these things together. And we'll see a little bit about this later. So why have a geological map in the first place? Well, there's various reasons for it. Simply for the science of the thing, simply to find out, what's there, to answer questions about what's in the ground, what's actually happening. For mineral extraction, well, obviously, a geological map's an important thing. It's important in agriculture and forestry. If you know what the rocks are underneath, that will give you an idea what the soil types are likely to be, how it drains, things like this, what the terrain's likely to be. So if you're planting anything, that would be quite important to know. For any sort of building or development work, if you're putting up a house, you need to clear a site. If you're going to be getting a rock pecker in to dig away at the rock, it's probably good to know what you're likely to be digging away at in the first place before you actually start. And also civil engineering, obviously. If you're building harbours and putting up bridges, then an understanding of the geology is going to be pretty critical. to the success of the project. So there's various reasons why you might want a geological map.
My meeting.
Looking at early attempts at the map, here are some of the people who were involved with the early maps. That's John McCulloch, and at the bottom there, the colour picture. That's McCulloch, who the famous McCulloch's fossil tree is named after. He was, by all accounts, was a bit of an odd character, but he did a geological map of Scotland, and Mull was part of that. And his name's forever associated with the famous fossil tree. The chap on the right is John Wesley Judd, who is another geologist who did quite a bit of work in this area here. And we'll see some of his attempts as well. And there's Sir Archibald Geekie, who was the head of the Geological Survey in Scotland, eminent geologist, and he produced quite an impressive map as well. So the Mull geology map through time, there was a man called Necker, produced a primitive map. Then there was McCulloch's. There was a chap called Knight, who churned out a pretty impressive looking thing. Then there was Judd's map, Geekie's map in 1910. And then we come to the original Geological Survey map of 1923. That's the one we're going to be looking at tonight. It was updated in 1992. And nowadays we've got the BGS online geology viewer map. So you can actually look at it in completely digital form. Here's an early attempt to draw a map of Mull. This is Blau's famous map. Loads of people in Mull have got this, again, hanging like a picture on the wall. It doesn't show much of the geology, but it shows the basic outline of the island. The Tyrrhene Col to the west, and Stafa's in there somewhere as well. They seem to enjoy putting these really fancy ornamental titles on them as well. We'll see more of that coming up. This is Necker's map, geological map of Mull. This is the first attempt at a geological map of Mull. And it's, I mean, Mull is a funny shape in this, and there's not a huge amount of detail. It's actually quite hard to work out what he was trying to get at here. But yeah, this was the original map that he did. And then there's McCulloch's map. This is McCulloch's map of Mull and Iona and the other islands round about. And you'll see there's some detail in here that's actually quite accurate still. You've got the Ross of Mull granite down here in the very southwest. You've got the metamorphic rocks round about Bunessen and Ardalanish and Ushkin. And then you've got all this stuff here, all this yellow stuff indicated. That's most of the volcanic rock that makes up Mull. Iona is picked out differently because Iona is different. And you'll see around the edges of this map, there's little blue streaks. That's some of the underlying older Jurassic rocks that you find around the coast and over in Inchkenneth. So there's a bit of detail coming in here. Not a huge amount, but a bit of it. And you'll also see in the area of Loch Ba, there's something unusual going on. He picked out something different there. So that was McCulloch's map. It's one of the early ones. This is Knight's geological map of Scotland, and there's a geological map of Mull as part of this. Here it is here. Again, Mull's a funny shape. It's like it's got a big bite taken out the southeast side of it. But again, you've got the Ross of Mull is different, the bit around about Bunessen is slightly different. Again, you've got all the volcanic rock that makes up most of Mull. And again, the ancient sedimentary rocks that underlie most of the volcanics pick these out around the edges. And there's also, again, in the area of Loch Ba, you can see there's something unusual going on here. He's obviously detected something different in the rocks. So the thing about Knight's map of, I mean, this is the Mull part of it, he did the whole of Scotland, is just incredible, as I said, the detail that they put in things like the headers and this, you know, I think he's used every font imaginable to try and create this title: lochs, mountains, islands, rivers and canals, railways and principal roads, and the sites of the minerals. Interesting sort of geological expression there. That's at the top of his map. And there's also this incredible cross section that you see here. That's Stafa out here. That's Ben Nevis. And this is various layers of rock. And I mean, this thing continues all the way to the south of England. It's a pretty impressive cross section. And I mean, cross sections are important because, you know, they can show you, give you an idea of what's actually happening below the surface. And, you know, there are some quite accurate cross sections being worked out on the basis of what's been found by mapping. And we'll see that with some of the survey map, the map of the survey. They've got cross sections as well. So yeah, it's quite an interesting. It's obviously quite enthusiastic with this use of colours, and Ben Nevis looks very high. This is Juds' map of 1874, and now we're starting to get the proper shape of Mull, as you can see. Again, Iona, loss of Mull, area around Benesson, and all this blue stuff, which is the volcanics, is it's really, you know, the detail is starting to come together here. You've also got the complicated bit in the middle, which is starting to take shape. And you'll see there's this big blue chunk here. That's the BenBuH gabbro by the looks of things. That's starting to take shape. So this is getting on for a much closer approximation to the modern geological map. And the thing about Judd's map is it's based on the work of the Ordnance Survey. So the shape of Mull is accurate. You know, this is the actual shape of the island today. So this is 1874, and we're starting to get towards the proper thing. Judd also included a cross section, and this is quite interesting. Not so much from the geology, but for some of the place names. Now, I've always been keen on Gaelic place names. I'm a Gaelic speaker myself, and in some of these old maps and papers and things, you've got names preserved that no longer seem to exist. Now, this thing called Craig Cragan is the hill called Bencraig Hore, which is between Craigmuir and Salem on that big long ridge. And you've got Pennygown with Farmers at this end here. So I'm pretty certain Craig Cragan is Bencraig Hore. The height of the hill here tends to corroborate that. But there's a thing here called Nida Shoig, which is Netjoig, which is the nest of the hawk. So there's this point which has got a name that is no longer used as far as I can see. So it's been preserved in this. So yeah, that's Judd's cross section. He's also got this one. This is a hill he calls BenBuH. But BenBuH is actually Benadura. It's near Btala in the centre of Mull. And yeah, he's got these amazing cross sections and things here. So there's, yeah, I mean, these guys were, you know, they were keen to show what was happening below the surface as well as what was on the surface. And also the volcanic plug to the north of Mull is called Sarsdeben, although it's called Sarsdeben here. But it's interesting, the actual mapping, because it just says bog, 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 bog around the side. And I can testify that's exactly what it's like up there, because I've been up there loads of times. And then you've got this volcanic plug with a loch in the middle of it, which is, I mean, that's exactly how it looks today. And you've got a nice cross section of it as well. So yeah, it's interesting. Just bog, very poor exposure, not a lot to be seen. And then we get Geekie, Sir Archibald Geekie's map of 1910. Now, Geekie made use of some of the data that the survey officers acquired through their mapping. So this map of Mull, this geological map of Mull, contains quite a bit of detail that the final published map contains. You've got the BenBuH gabbro down here, for instance, and you've got all these dikes, these red streaks running northwest, southeast. And again, you've got the older rocks around the coast in various places like Carseg, Greeburn, around the Lagan Peninsula, over at Craigmuir. So, yeah, Geekie's map is, yeah, it's really coming together now. We're really starting to see what the final map looked like. And here it is. That's the map that the officers of the Geological Survey published in 1923, 100 years old this year. I'm not sure what month it was published, but it was just the year was 1923. And that's what it looks like. That's the final product. It's been updated a bit. This is the 1992 version of it. Now, it's interesting because there's not really many changes to the actual geology on the map. they've made the colours pastel rather than more intense because it, I think it makes it easier to see. But all the rock types, all the geology that's on here is basically the same as what's on the original map. And the reason it's like that is because those guys that did the original mapping, they got it right first time. You know, they actually, there was no need to revise much of this. It was what these guys did 100 years ago was, you know, how it actually is. It was quite a remarkable achievement. Like, you know, in 1992, there wasn't really any need to do much of a revision of this. All they've done is change the colours to make it a bit easier to see. And then we've got the geology viewer from the BGS. And this is electronic, this is online. You can actually zoom in to any bit and it will give you information about it. So the Geological Survey itself it's part of the Ordnance Survey. So it's, you know, it's basically a military operation, the Ordnance Survey. And the Geological Survey was derived from it. It's established in 1835. First director was Henry de la Beche. And it's the world's first geological survey. In 1965, it became the Institute of Geological Sciences. And in 1984, it became the British Geological Survey, BGS, as we know it today. In Mull, the Geological Survey, the work was carried out in the early 20th century, up until about World War I. It was based on the old 6-inch and 1-inch maps. And the teams worked mainly during the summer. Very different conditions from today. I mean, transport would have been, you know, quite challenging then. You know, the roads and just connections would have been fairly tricky. They would have had basic equipment. I mean, the sort of hammers, pretty much similar to what we use today, I suppose. With no electronic equipment, obviously. The clothing that they would have worn, it would have been like the mountaineers of the day. You know, nailed boots, tweeds, that sort of stuff. Very heavy. The maps that they used were the old 6-inch maps, didn't have contour lines on them. So it was very difficult to actually work out what the terrain was actually like. So it was quite a challenge. Now, I'll talk about the challenges a bit later. Accompanying the map was the memoir. Now, the memoir is an extremely important document. It goes hand in hand with the map and basically explains what's on the map. It's quite a mighty tome. It's, I almost think it reads like a doctoral thesis. It's some serious detail in there. It was a hugely influential book. It's fair to say it's a milestone in the history of igneous petrology. And it's still very much an important go-to book today. Anyone doing any research on the geology of Mull, it's really going to be one of your starting points. What does the memoir have to say about it before you go into the field and actually start looking at it? So it's a very, very important document. Now, I don't know if there's any plans to celebrate the memoir next year because it came out in 1924. So it's 100 years of the memoir next year. It'd be good to do something about it. It's perhaps not as, what's the word, appealing to the public as the map perhaps is, but it needs to be celebrated, I think. This is what it looks like. Fairly austere looking document, that's the front of it. It's got the names of the survey officers listed here who took part in the survey. And yeah, it's a very, very important document. The Mull survey, they basically worked from the 1-inch map sheets that were available at the time. And as you can see, there are multiple sheets that make up Mull. Northwest Mull is in 51 East. This western part of Mull is sheet 43. Sheet 44 is the one that we're mainly interested in tonight, because that covers the biggest part of Mull, including the complicated bit in the middle. But there's other little things as well, like sheet 35 covers a little bit south of Mull. And also sheet 36. Sheet 36 covers this tiny, tiny little bit of Mull here, which is actually where the karstic arches are. So you've got one of the most interesting geological sites in Mull, just on the corner of this sheet here. So the way that they worked is they worked systematically through the 1-inch map sheets. So if there was a bit of Mull in it, even though they were doing, this is the north end of Jura, or this bit here is Colonsay. So even though they were mapping part of that, they also did these other bits that spilled over into the map. So the Mull survey, this is the order in which it was done. Dr. Harker did that Malcolm's Point. That's where the Carsick Arches are. That's part of the Kilmartin sheet. That was 1902. A proper start was made in 1907 with Mr. Cunningham Craig in the Ross of Mull, the Ross of Mull that I showed you there. And then the main survey started in 1907 with Edward Bailey and his troops. Sheet 44 was finished in 1914. So that's like 7 years, really. You know, it's quite remarkable what they did. 1920, sheets 43, 51, 52 were finished, and in 1923, the main map was published, Memoir in 1924. And since then, in 2010, there was a new map of North Mull and Ardnamurchan published, which is a fairly impressive bit of work. That's what it looks like. That's Mull here. The north part of Mull, the geology is fairly simple. Here you've got the Ardnamurchan Central Complex with its famous ring structures. So Ardnamurchan and Mull are very closely related, not just that they're close together, but the geology is quite similar in a lot of respects. And I mentioned cross sections, and there's a nice modern cross section along the bottom. So that's 2010. That map's worth getting a hold of because the detail in it is absolutely superb. This is some of the chaps who took part in the survey. They're very much dressed as they would have done in those days. As you'll see, it's all men, no women, very much of its era. Beards, moustaches, pipes and bonnets have the order of the day. And there's some more of them. You'll see C.T. Clough gets mentioned there. Clough was killed in a railway accident. He was doing some geological work in a cutting, I think it was, or a tunnel, and a train hit him. And here's another picture of them. Very sort of somber. But yeah, that's what the men looked like who did the survey. And here's Edward Bailey himself. This was the main man. Bailey was the lead surveyor, and the way he dressed is quite remarkable. He used to like wearing shorts, apparently, and he's got shoes. That doesn't look like proper footwear. Somebody said he looks like a real hipster. I mean, just looking at his haircut and everything, that looks quite modern almost. Apparently, Bailey he didn't like socks. He used to rub fat on his feet and put them in his shoes. And there's a story about this fat ball, which was eaten by somebody's dog in the village of Salon, which he wasn't very happy about. So, it's quite eccentric. And there's the stories about Bailey. As soon as he left the house, the lodgings in the morning, he would immediately eat his lunch so as not to waste any surveying time on the niceties of having lunch. Get it out of the way. And I think it was Bailey who was one of these people who used to immediately get his feet wet because they were going to get wet anyway, so you might as well start off like that. And that picture on the left there is, in the snow wearing shorts. Yeah, quite a character, but a tremendous surveyor, a brilliant field geologist who did some incredible work. Some of the language used in the memoir and on the maps is very much of its era as well. Here's just some examples. The Loch Ba ring dike is the most perfect example of a ring dike known to science, which is, the idea of something being most perfect, very unscientific language. But yeah, they're obviously so taken with it. There's other things like this, describing the fossil tree and that area around about there. The lava enveloping the trees is a wonderful mixture of solid columnar basalt and vesicular slag that rests on red ash. I mean, these are great phrases, wonderful mixture. And McCulloch's tree, described as another tree, is lying prostrate, 10 feet, enveloped in basalt. And there's this phrase here, which I think is one of the best from the memoir, talking about the augite of the plateau basalts. It says, the purple colour is apt to be particularly marked towards the margins of crystals and presumably bespeaks titanium. I have to thank Dr. Bob Goody for bringing that one up because he drew our attention to it. Bespeaks titanium is a phrase you don't hear every day. Yeah, that's the sort of language these guys used. So making the map, how did they actually make it? They used field slips, bits of paper based on the 6-inch map. These were then combined into a much larger map and then scaled down to 1 inches to the mile and published. So what they did was they used the 6-inch maps as their base maps. And these here, this is taken from the original map, and this is from the latest, the 1992 version. And you can see the individual 6-inch sheets that make up the 1-inch sheet. So there's the work from these things. That's what the scale they were working at, 6 inches to the mile. And this is what a 6-inch map from then looks like. This is actually just up the road from where I am at the moment. And as you can see, there's spot heights, there's streams, there's a loch there, a few place names, and not much else. Lots of symbols to indicate the type of vegetation, but that's about it. So it's a pretty basic map. You know, there's not a lot of detail on it, but they got to work on these things, and this is an example of a 6-inch map field slip with some of their notes actually on it, with incredible detail, very small print that they wrote on these maps to indicate the rock types and what they were seeing in the field. And this is just an enlargement of it. This bit here, Crignahulera, up here, this is like the northeast end of BenBuH. And there's some incredible detail in this here, serious amounts of detail. You know, it's not just they didn't just indicate the rocks, they put notes on it as well. And one of the interesting things is on the back of these field slips, they would put holes in the front, and on that pinhole at the back, they put more notes. So there's lots of little holes in the front of the map that relate to these comments on the back. So there's an incredible amount of detail. It's like they didn't seem to use notebooks at all. I mean, nowadays, if you're doing any sort of field surveying, you would use a notebook. But no, they did it on the actual field slips. And here we are. That's these little marks there, these dots. That's the pinpricks, a circle drawn around about them, and a number plus details of what's actually happening there. So there's an amazing amount of work actually gone into this on both sides of the sheet of paper. And finally, these things are all combined into this, what we call a clean copy. And the detail in this is unbelievable. When you see this thing full size, it's quite remarkable. And you can see the ring structure that are based on the centre 2 of the Mull complex, the mountain called BenBuH, and these ring structures there going around it. Phenomenal amount of detail, absolutely phenomenal. And this is just a little close-up of it. There's BenBuH on top of it, plus various ring-shaped structures around about it. And in the margin of the map, you've got the names of those who did the surveying and the dates. And you've also got this little diagram showing who did which bit of the map, how they split it up between themselves. And hopefully, if there was a piece of rock on one side of a border and also on the other, that the two matched up. I'm sure there was maybe a few nights spent debating that type of thing. But yeah, they each had a bit to do themselves. And that's the final product, or the final geological map that was put together from all that detailed work. So it's really a distilling down process that they produced that amazing clean copy map that was full of detail, and then they reduced it to this, which is much more manageable. So I just want to say a little bit about Mull's geology, just to try and simplify it. Because you look at that map, this is unbelievable, complex stuff. So Mull's geology is, it's like it's in layers. You've got some older rocks that form the basement, and most of these are of older metamorphic rocks with a lot of sedimentary rocks of Triassic, Jurassic, and Cretaceous age over the top. And these are probably found, if you were to drill a hole anywhere in Mull, you'd find these underneath. Most of the volcanic activity in Mull is from the early Tertiary. And the first thing that happened is you've got these, what they call the plateau lavas fed from fissures. And these great lava fields spread out. And that's that pink stuff that you see around about the edge of the map. And then a little bit later, you've got the central complex, the central volcano. That's the complicated bit in the middle. And since then, it's been erosion and glaciation. So a few diagrams to illustrate that. Here's a simplified geological map from Scottish Natural Heritage. And this green, it's not shown as pink, it's shown as green here. But these are the earlier lava flows around the edges. And this bit, this complicated bit, this is the main central volcano in the middle. And around the edge, you can see this yellow stuff. That's the older underlying, this brown stuff here, that's the older underlying rocks that all this lava was poured out over the top of. And there's this neat diagram from the SNH book, Landscape Fashioned by Geology. And that shows you the older metamorphic rocks underneath ancient stuff, 1,000 million years old, twisted, contorted, and quite folded. You've then got, over the top of that, you've got the, what I call the Middle-Age rocks, the Triassic, Jurassic, Cretaceous rocks, not nearly so folded, but underlying the lavas, which is this green stuff over the top. And the whole thing's shot through with dikes and various things like this. And this landscape we see here, where it looks like terraces, that's the distinctive track featuring, as it's called, that's so well seen when you're in a place like Artun looking over to Iona. It's the terracing is really, really pronounced. So this was the early stages. This was the first volcanic activity, produced these layers and layers of lava. And then here's a great picture. You had your central volcano, which was poked up in the middle of all that. This isn't from the memoir. This is from a book called Tertiary Volcanic Districts. I quite like this. It's got a good sort of period feel to it. This is a more modern representation of the Mull volcano, taken from Landscape Fashioned by Geology, a nice block diagram, and it shows you various things which I'll be talking about. So, I mean, the thing is, you've got to remember is that there's been quite a bit of erosion since all this activity finished, and this blue line here, that represents the present-day erosional surface. You know, they reckon there was about places like BenBuH were about twice the height they are today. So there's quite a lot of material being removed through erosion over the past 60 million years. So it's not just the map. There are other images associated with it. There's cross sections in the memoirs I mentioned, and there's other diagrams and maps used as well. And some of them are amazingly detailed. The memoir is full of these examples of diagrams and little maps taken from the main map. I mean, this is an amazing piece of work. This is BenBuH, really, this stuff here in the bottom right-hand side. And this is a cross-section of it, showing the various things, the various intrusions, dikes and Conshetes and all, what have you, cutting across. And so it's an amazing detail in that. You know, this is there's a lot of work gone into producing this sort of cross-section. And this is another one. This is the Goodall River up Glen Forsell. And they must have gone up that river, measuring it almost inch by inch to find out what the rock types are. That's what all this lot is. And the Goodall River runs up here. So they've got all these different rock types indicated. You know, they're all inclined sheets. And it's quite a remarkable piece of work to produce a cross-section like that. That really is quite a bit of work. So the challenges that they had in those days, I mentioned earlier, was things like transport, terrain, the equipment they had, clothing, pretty basic accommodation, and there's specific geological challenges as well that I want to look at. This is some information from the memoir, which tells us this: the mountainous district where the complicated geology lies. It's largely given over to deer stalking, and strangers are not welcome off the beaten track during August and September. There are but few hotels or inns. But on the other hand, there are cottages and farms ready to take people in if arrangements are made. You know, very different today when there's lots of accommodation. Most of the roads, with the exception of the Glenmore Road connecting Loch Spelvey and Loch Screeder, are traversed by postal gigs. I think postal gigs is a fantastic word, or motors on steamer days. And geological visitors to Mull must be prepared for bad weather and also for difficulty in obtaining quarters. Well, getting accommodation isn't so hard, but the bad weather's still a thing you've got to factor in. And also the business about deer stalking. I mean, there's a large parts of Mull are big estates. So anyone who is doing any survey work, doing any geological field work, you have to be cognizant of that and check with any of the state offices if they're planning on going out at that time of year. Some of the geological challenges, there's a few of these I just want to mention. Poor exposure, alteration of the rock, and what are called Conshetes. And I'll just have a wee look at these. Poor exposure, well, grass, heather, bracken, trees, and other menaces, rhododendron, just grows really thick. Sometimes ask the question, was it quite so bad 100 years ago? I don't think the rhododendron would have been quite so bad. It would have been, it's bad today, but that stuff really spreads, and it just completely obscures whole areas. One of the important things for coping with this is our stream sections. Where you've got a stream, the rock is frequently exposed, and you can work out the geology from going up these streams, even though the areas in between the streams are covered in grass or whatever. Plus, the other thing, of course, is that these guys had excellent fieldwork skills. They really knew their craft. They really knew what they were doing, and they did it very well. So here's an example. I took this picture just a couple of days ago. This is the sort of thing that you've got just up the road from where I am. A few trees, lots of bracken there and grass. On the higher ground, you see lots of bare rock. And where there's a river or a stream, you'll get it as well. But there's a lot of this lower ground that's really badly exposed. Like this here, that's BenBuH in the background. And just got acres and acres of boggy land with grass and tussocks and stuff like this. And then you get something like this, that's Btala in the background. This is called the Conshetes, this stream coming down here. There's lots of nice rock exposed in there, and there's a little bit here in the road cutting as well. So there's a few places where you do find actual rock, but the stream sections are really important because that's where you really do. That might be the only place you actually see it. And then the forestry plantations, they add their own challenges. That's Btala. Once you get up on top, once you get up to the higher ground, of course, what do you call it? There's lots of rock to see, but it's these lower reaches that are the real challenge. I mentioned alteration of the rocks, and this is a major thing in Mull. The rocks in central Mull, a lot of them look very greenish. They're all altered. They're being modified, and that's by what's called hydrothermal alteration. You've got, this map, this thing here is a good cross-section of what the place would have looked like. Today's erosional surface, where is it? It's on here somewhere. It's about, where is it? It's about here. But what you've got are the rain, groundwater, going through a hot volcanic system. I mean, when the volcano finally finishes erupting, the activity doesn't completely stop at that point. It can keep going for quite a long time afterwards. And that process of groundwater running into the system and being circulated through it can create all sorts of alteration of the rocks. And that's what's happened in Mull. And the rocks, if you look at the rocks in the central area, a lot of them look very greenish. And that greenish tinge is due to alteration, hydrothermal alteration, it's called. So yeah, it's a major problem because a lot of the rocks, they just look horrible. Conshetes. I mentioned conshetes. What are conshetes? Well, this is how they're represented on the map. These green lines, these stringy green lines that you see, and their Mull is absolutely full of conshetes. So, what's a conchete? Well, when you've got volcanic activity, you've got this hot material being pushed up. And what happens is, round about the volcano, you get these circular fractures opening up. It says conchete there, these red things here. And these can go to the surface and act like little fissures where lava will come out. So when these things, if you've got hundreds of these conchetes, it really complicates the geology, which is what is the case in Mull. Also Ardnamurchan, there's a lot of them in Ardnamurchan. And what can happen is you can have so many conchetes that there are more actual conchetes than there are the rock. that they've been intruded into. So it makes for a very, very complex picture. That's a single cone sheet, that thing there, that outcrop of rock with a yellow lichen on it. That's down at Loch BenBuH. So that's okay, that one, that's just one cutting across the rock. And they all tend to dip towards a common centre. This is how they're represented on the map. Again, this green thing here, you see, that's the cone sheet at Loch BenBuH, and that's called Moor here, with these green lines or cone sheets cutting across it. And that line there indicates a fault. There's been a bit of movement on the rock. So that's how they're indicated on the map. But you can get situations, and this is just up the road from where I am here, where there are so many cone sheets. This green stuff represents cone sheets, that there's more cone sheet than there is actual country rock round about. And what they've had to do on the map is put these black lines like this to indicate where the boundaries are of the rock that they're interested in. There are so many cone sheets cutting across that they've actually had to delineate it with this these thick black lines. And as far as I'm aware, the Mull map is the only one that's got this feature on it of these thick black lines to indicate approximately where the rock is. I mean, the rock that we're looking at here is this this pink stuff, this Triassic sandstone. But there's a lot less of that than there is the actual cone, this green stuff. These green things are the cone sheets. And there are so many cone sheets that they're all bunched together as one big mass of green. So it's quite, it makes for very, very complicated mapping. And that's how it's represented. So that really complicates the map enormously. So making a bit more sense of the map, there's various colours, symbols, lines. There's little maps around the edges and notes as well. So if we look at the different colours represent the different rock types. So this brown is gabbro. This blue is a gabbro as well. That's the famous BenBuH gabbro. This light pink is the various lavas, and this pink stuff, this darker pink, is a type of granite called granophyre. And this green things, these green things here, that's the cone sheets again. There's this OG here. It's another type of granite. So there's a lot of there's a lot of nice colours on the map. But when you go out and look at these rocks in the field, they're grey, they're blackish grey, they're brown, they're brownish blackish grey, dirty grey. You know, if the rocks in the field look nothing like the colours on the map, and if the colours on the map were actually the same as the colours in the field, it would make the geological map incredibly difficult to read. So the other thing that you'll find is that they don't just put in the colours, they also use a lettering as well. So there's a G indicating granite, there's ED representing a type of gabbro, there's a Z here indicating a pyroclastic rock. There's these extra lettering put in as well as the actual colours. And round the edges of the map, you've got the guide to what these different rocks are. Each colour and the name of the rock, what it is, all split up into sedimentary ones are listed separately, and igneous rocks are on their own as well. So it's all very clear around the edges what the rock types actually mean. And there's various symbols as well, generally indicating the orientation of the rocks. Most of these are to do with whether they're dipping or horizontal or whatever. There's an interesting one here. There's a coal seam actually indicated on the map. It's down near it's on the cliffs above the Carsic Arches, and it's a place called Btala, and it's actually marked on the Ordnance Survey map. The Gaelic name is called Altagua, which means the stream of the coal. So you know this coal seam that's on the map is actually indicated in the Gaelic name as well. So other symbols that you'll see these lines cutting across, these black dotted lines, and these represent faults where there's been movement across of the rock, and it's caused displacement and crushing things. So when you get faulting of the rock becomes loosened, it becomes weakened, it becomes crushed, and it's easier to erode out. And sure enough, when you look at the aerial map of that, you'll see these lines cutting across, these gullies, these glens, all running in the same direction. And that's where these faults are indicated on the map. So, by looking at the aerial image, you're actually getting an indication of what the geology might be underneath. All these little gullies and glens running northwest, southeast. There must be a good reason for that, and that good reason is because of all these faults that have developed. Another thing that runs northwest, southeast are dikes. There's lots of dikes on the wall on the map. They tend to run northwest, southeast. They're shown as thin lines, but they're not to scale. This is a thing to be aware of. Got some examples of this. This pink stuff here is basalt lava. This is on the old map, this is on the newer one. And these little darker pink things cutting across the stream represent dikes. Now, the thing is, the dikes don't start and end as little short things like this. The reason that they're indicated like that is that's the only place they were able to see them, and they weren't able to follow them much across country. And you'll see that some of the other ones, there are indications of dikes further away from the stream, but in the vicinity of the stream itself, the dikes are easy to identify. Again, it's this business about stream sections. Stream sections allow you to see the geology in great detail, but once you get away from it onto the open moorland, they can be much more difficult to follow. So these little red lines that you see here, they probably go much, much further than just the stream itself. Almost certainly do. And you also see on here, there's these little black lines, several of these black lines. These indicate individual lava flows. So when you get a lot of these, you'll get a terracing effect in the landscape. So other information on the BGS map, there's smaller maps at the bottom. There's a written explanation at the left-hand side, references, and there's information on major igneous rock types, which we'll see. I'm not going to get too involved with this. These are the complicated bit of the map. They've broken it down into the various igneous centers and the various focal points and try to simplify it a bit. So that's extra information that's given on the newer map. There's also a panel showing you the different different types of igneous rocks. And some of these are quite interesting because of the names. You'll see there's one called BenBuH, named after Ben Moore in Mull. There's Craigneurite, there's Inanmorite, there's things like Alavalite, that's named after Alaval in Rum. And there's a rock type called Muggerite, named after a place called Mugere in Skye. So I mean, what these names indicate is how important the Hebrides are to the development of igneous petrology. Igneous geology owes a lot to these places. The names are in the rocks now. So moving on to the future mapping, paper maps, will they still be published? I would like to think so. Hope they still get published. There's definite advantages. You can quickly open out a big paper map and leap from one bit to another without any, very, very easily. You get a good idea of the overall scale of the thing. The thing that's important now is digital mapping, doing it on computer. 3D printed maps might be a thing as well. Mapping in the field with tablets and the use of drones to do the geology. With a geologist who's at Aberdeen University called Jess Pugsley, and Jess did her PhD in Mull, in northwest Mull, looking at cliff sections, and a lot of that was done using a drone. And she was able to get into places that you would simply have had to, well, they've been completely inaccessible, and the only other way you could have got to them would have been by abseiling. So drones allow you to look at some, amazing detail. The cameras on these things now are great, so you can get information out of rock faces, cliffs, and things, which would be otherwise really, really difficult to do. And the other thing, of course, I mentioned earlier, is the geology view, which is an online geological map, and because it's working from an online database, if there needs to be any changes made to it, it's easy to do. If you have to make a major change to a paper map, then that means republishing it, and that's a big job. So with digital, it's easier to do updates. That's an example of a 3D printed map. I came across a thing on Twitter. It was students from University College London were doing mapping in the Northwest Highlands, and they were using 3D printed maps for their mapping exercise, which I thought was quite neat. That's what that one looks like. This is the geology viewer. I was talking about the actual online thing. on the BGS site. And you can zoom right in on it and get an idea. If you click on it, you right click, it will tell you information about the rocks at that particular point. And obviously this can be updated much more easily than a paper map could be. So this is very useful. I think it's an addition to the paper map. I think I'd like to see the paper map still published, but this is certainly, you can get an awful lot of information on the one website or something like this. So you can get digital geological maps with specific data, which this is something that one of my colleagues, geologist, well, she used to work with BGS, and her name's Rachel Ellen. She's now with Esri, and she was able to produce these images, which I'm just about to show you, where you can look at specific groups of rocks on the map. You create a map with just specific outcrops of rocks. So here's the rocks of Mull by era, different geological eras indicated. There's, the individual rock types themselves are all mixed in together, but the ages of them are indicated by what's around here. And you can also do it by what's called group. Certain rock types fit into specific groups, and that's what we've got here. This is one showing the central complex on its own, and its various bits spread out from it. So that's the complicated bit in the map, isolated effectively. This is the geology at 1 to 50K scale. This is the whole of Mull. And this is the Archean. This is the ancient stuff in Iona indicated here. We only find it in Iona, but none in Mull. This is what's called the Neoproterozoic, the old metamorphic rocks in the southwest of Mull, and also a bit of this over at Loch Dawn and around the Greeben coast as well, and on the side of Iona. So you can actually bring out specific ages of rocks. This is the Mesozoic geology. This is what I call the Middle-Age rocks. Again, these are the ones around about Carsigg and Lagan, over at Loch Dawn, Craigmere, and over on the Greeben shore as well. There's also little outcrops up and down this off the east coast. This is the Cenozoic geology. That's all the stuff from 60 million years ago onwards. And as you can see, most of Mull fits into that. I mean, most of the landscape of Mull is actually quite young, geologically speaking. It's no more than about 60 million years old, majority of it. So that's a great thing about geology. You can say things like, oh, it's no more than 60 million years old. It's just a new kid on the block, really. And I've got a video fly through here, so hopefully this is going to work on Zoom. Let's see what happens. There we go. This is the geology map draped over a 3D topographic map. So it's quite neat what you can do. All this digital technology allows you to do stuff you could never have done in the old days. So there you go. 3D fly through. Here, next slide. Yes, and you can even produce a Lego map of Mull using this sort of technology. So just a little whimsical thing that Rachel put together. So I'm going to finish off with some old photos, just to lighten the mood. This is found on the BGS Geoscenic website. The Geoscenic part of the BGS site is great. There's huge amounts of material there. There's pictures of rocks, pictures of scenery, the BGS personnel. There's a lot of good material. So that's the Carsigg Arches. I don't think it looks a lot different today. Apparently, when when they were doing the survey, the guys didn't take their own photos. they had a photographer that would be brought in to do the specific photography. So it's the Carsic Arches. And as I mentioned earlier, that was actually the very first thing in Mull to get surveyed, because it was part of the Kilmartin sheet. That little bit of Mull just happened to poke into the corner of a Kilmartin 1-inch sheet. So this was the first thing, the very first thing to get surveyed. This is Loch BenBuH. I've mentioned Loch BenBuH quite a lot. That's Eilean Mor, where the Conshetes were, I mentioned. This is taken above, looking down. If you look at this image on Geoscenic, you'll find it's actually flipped. So the negative must have been scanned back to front. But yeah, I've just reversed it. And there's the famous fossil tree, Molock's fossil tree. Again, it doesn't look a lot different today. And that's BenBuH, taken from the Lagan beach area. And again, I mean, that still looks pretty much the same, pretty much as it was. And that is Stafa. That's the columnar basalt of Stafa, heading out to Fingles Cave. And that's the little island of BenBuH, the herdsman that's just beside it. So finally, I just want to acknowledge a few people and say thank you to Dr. John Faithful for helping so much with this project and doing the talk at Craig and the beach event, which was a real success. I want to thank Dr. Bob Goody for reminding us that the map was actually 100 years old this year, but we would have forgotten about it, I'm sure. I want to give thanks to the BGS staff who've been involved in this. There's Rachel Talbot and Bob McIntosh who did so much to let's get the material that we needed to do this. And also I want to thank the staff at Untoper and Craig Hall and at the MICT office and Craig Muir for all their help and assistance with doing these presentations and things. It's been really good. And that is basically it. I want to say thanks for the Scottish Geology Trust people. Thanks to Katie. Thanks to Emily for what they've done to get all this together. And that's it. So there might be something on the memoir next year. Never know. Might be somebody else who's doing it. But follow the SGT, Scottish Geology Trust website for any details of any projects that might be happening to do with that. And I shall bid you farewell. Thank you.